chord. There we go. All right, so this is page 100 in your math journal. And what we're looking at is problem 1. And you're going to circle all of the polygons that have multiple or 2 sets of parallel sides. So go ahead and try and do that. Again, to be parallel we think like railroad tracks. And to have 2 sets of, if it only has 4 sides, a set needs 2. So it basically means each side has a parallel side. I'm struggling to kind of explain to you guys how to say that, I guess, but it's okay. You guys will get it. I believe in you. Okay, PCAT, come up and show us one of the polygons that have 2 parallel sides. Okay, explain.
So what we try to extend the lines, it wouldn't touch. Same thing with the other way, which means both sides are parallel.
Very good. Excellent. Is there another one? Mackenzie. Okay, explain.
Because this one, if you extend them longer than the other one, and these ones won't be this, that makes it better.
Very, very good. Okay, is there any others? Believe. Explain. I feel like you guys know I want you to explain.
If you go this one on every side and the other.
Very good. It's kind of like tic-tac-toe. How about this one? Does this one work?
No.
Okay, is it top, bottom, left, or right that ruins this one?
Left and right.
It's the left and right. Really, it's the right side that's the problem. Right? Okay, very good. You did a great job there. Number 2, circling triangles that appear to be right triangles. Circle the triangles that appear to be right triangles. Who needs more time? Anybody need more time? Anyone? You are? Okay, show me the first one. Elizabeth, which is short for Elizabeth.
This one because it has a 90-degree angle.
Yep. No, you did a fine job. You did a fine job. Show me another one, Braxton. Porter.
Oh, it has a lovely angle like this.
Okay. Macy. Yeah, that one's a tricky one. They turned it on you. Yeah, this one was tricky because they turned it on you. You look right here, pretty close. Yep. So they tricked you on that one. Tricky, tricky. All right, this one. You're circling anything that does not have a parallel side. Does not have a parallel side. No parallel side. Anybody need more time? Okay, Chase, tell me about one. Chase? Chase? Chase, talking. No,
He isn't on duty.
no. Roger, go ahead. Roger, I said go ahead. Very good. Explain.
Because if they go home sleep, if they don't,
Very good. Okay. Bradley, any others?
this one, touch, this one.
Well, and actually, I'm going to show you something here in just one sec. It's actually, you're actually doing the ones that are side by side. It's actually this one and this one that are okay. Because you kind of have to skip one. And then it's this one and this one. This one's a... All right. Now, this time you got to remember what perpendicular means. Circle the shapes with perpendicular sides. Perpendicular sides. Ha! Sure. I've been looking in my notebook the whole time. Yes. No, just one perpendicular side. Or I guess two, because you need two sides for it to be perpendicular, right? Okay, show me one with perpendicular sides, Ray Lily. Ah. Okay, prove it. Ah. But what does perpendicular? Those are intersecting. What does perpendicular mean? But when they intersect, they make what? What kind of angle? Okay, so that one is, it does have perpendicular sides, but which one is it? Yeah, right there. Yep, absolutely. So in reality, we should have been looking at this, making perpendicular, right there. Okay, Gavin. Okay, where's the perpendicular? Yeah, we see it's a darn smart board again. But yeah, you're right. It's the right side and the bottom. Very good. And yeah, what? Oh, it could be the left side. You're right. Very good. Maddie. How do you know? Basically, everything is perpendicular, yes? Okay, Autumn, you're the only one who didn't get drawn, so why don't you come explain why this last one isn't, it doesn't have perpendicular lines. Very, very good. Excellent. Okay, we're going to look at 101, which is our math boxes. Ah, what? Exactly. If it has a right angle, it's perpendicular. And if it's perpendicular, it's a right angle. Ooh, very good. Yes, yes. All right. We've looked at ones like these before. And 1600 kind of confuses kids. But here's how I would think about it. Watch. Watch. Some of you are going to mess this up. 16, and it's telling you 1600. So it's like 16 times 100. And then compare that to 1,600. It might make more sense that way. It's the same thing as this, like 12 times 100. You may actually have to do that somewhere. But it's not that hard because all you do is 12 times 1 and then put your zeros at the end, right? Yeah. You good? Okay, and then make sure you're paying attention because sometimes it says greater than, sometimes less than, and sometimes equal. Okay. Questions on box 1. Number 2 says divide the 3 graham crackers to show equal portions for 4 girls. Show 1 girl's share. So here are your 3 graham crackers, and 4 girls want to share them equally. You're going to split those, then tell me what fraction they would get of a cracker. Then find an equivalent fraction. So when you're doing that, what you want to do is multiply the numerator and the denominator by the same thing. Make sense? Here it says, find an equivalent fraction to 4/5. And when I look at that, you're only throwing in 1. So there's only one equivalent fraction to 4/5. On these, you're drawing them so that they're symmetrical. They have to be perfect or they're going to be wrong. So, well, well, you definitely won't be able to with that attitude. That's actually true. Oh, no, the attitude was that you couldn't do it. Now this one's saying, how did you know that the fraction, which fraction was equivalent to 4/5 in this one? How do you know which of these is equivalent? You guys good? Okay. I think it's pretty easy when you're done. Choose one of the things to do when you're done with work, and then I think we'll have time for science today. So best of luck. Now I stop share. Yeah, what's up? I just got Chase in. So what's up?
So I can, is it okay, like,